Learning outcome 1.2 Scalars and Vectors. At the end of this chapter, students should be able to first, define scalar and vector quantities. Next, resolve vector into two perpendicular components, x and y axis. Illustrate unit vectors I, j, k in Cartesian coordinate. State the physical meaning of dot or scalar product. And the last one, state the physical meaning of cross or vector product. 1.2 Scalars and Vectors. Scalar quantity is defined as a quantity with magnitude only. Example, mass, time, temperature, and another basic quantity. For mathematics operational, we can use the ordinary algebra, meaning that you can add or subtract the value. But vector quantity, what is meant by vector quantity? Vector quantity is defined as a quantity with both magnitude and direction. For example, we have displacement, velocity, acceleration, force, and so on. For mathematics operational, you have to do a vector algebra, meaning that you can only add or subtract based on its component only. Resolving a vector. How to resolve vector into two perpendicular components, x and y axis. So we have two methods, based on the angle that had been chosen. For the first method, the angle is chosen from the x component. But for the second method, the angle that had been chosen is from the y component. So, for the first method, we have a vector of r with an angle theta from the x axis. So that you should know that this is your rx or the vector r on the x component. And this is your vector of r on the y component. So, your Rx now is adjacent to the angle theta, and your Ry right now is opposite to the angle theta. By refer to the law of trigonometry, for cos theta, we know that cos theta is adjacent divided by hypotenuse. So, by refer to this figure, your adjacent is Rx and your hypotenuse is vector R. Therefore, when we coming out the Rx as the main subject, so Rx is equal to the R cos theta. From this figure, you should know that this is also refer to the same value of Ry. So when we refer to the sin theta, which is opposite component divided by hypotenuse component. That's why we got sin theta is equal to the Ry divided by vector R. So when we coming out Ry as the main subject, so we have Ry equal to vector R sin theta. For the second method, the angle is from y component. So that this is your vector R on the y component and this is the vector R on the x component. And by refer to this figure, this value is also same as Rx. From trigonometry, we know that cos theta is referred to the adjacent of the angle phi to the hypotenuse, which is vector R. That's why we got cos phi is Ry divided by vector R. And for the Ry is equal to the vector R cos phi. For sin phi, which is know that sin phi is opposite divided by hypotenuse. So that for sin phi, it is Rx divided by vector R. So that for the Rx, we got R sine theta. To calculate the magnitude of vector r, the formula is magnitude r or vector r equal to the square root of rx square plus ry square. And to determine the direction of vector r, the formula that we should use is tangent theta equal to component of ry divided by rx, or theta equal to shift tangent ry divided by rx. Unit vector also can be written as vector r, rx vector I plus ry vector j. Example 1.4, we have a particle S experience a force of 100 Newton as shown in figure above. Determine the x component and the y component of the force. Okay, if we refer to the figure, so we have a vector force here, okay, at angle 210 degree from the positive x-axis. So to resolve this vector into the x component and the y component, you should choose an angle which is less than 90 degree. So by refer to this figure, the angle is actually 30 degree from the x-axis, meaning that we are refer to the first method, angle from the x-axis. And you should know that this is your force that exert on the x component, and this is the force that exert on the y component. At the same instant, you have to consider the sign for the component, either positive or negative. So, for the Fx, or the force that exerts on the x-axis, since it is directed to the left, so that the Fx is negative. The same thing goes to the Fy, since it is directed downward. So, your Fy is negative. Unit vectors. Illustrate unit vectors I, J, K in Cartesian coordinate. So we have notation vector A, vector B, vector C. So for the example, we have a unit vector A, which is a vector with a magnitude of 1 unit in the direction of vector A, which is magnitude of vector A equal to the vector A divided by magnitude of vector A, which is equal to 1. So this is the figure. So we have a vector A of a 1 unit in the direction of vector A. So unit vectors have no unit, and unit vector for 3 dimension exists. Refer to the, for the x-axis I, y-axis j, and for the z-axis k. And magnitude of I equal to the magnitude of j equal to the magnitude of k, which is equal to 1. So for a vector that have x component or vector I, y component or vector j, and z component or the vector k, the vector can be written in terms of unit vector as vector r equal to the rx vector I plus ry vector j plus rz vector k. And the magnitude of vector is vector r equal to the square root of rx square plus ry square plus rz square. Example, we have a vector S, which is 4i plus 3j plus 2k meter. So, the magnitude of vector S is square root of 4 square plus 3 square plus 2 square, which is equal to 5.39 meter. But actually, where is the position of vector S? To determine the position of vector S, it is easier for us by refer to the position of a box. In this example, your box is in the positive x-axis, upward on the y-axis, and in front of the z-axis. So that, okay, we sketch the box. Remember, your box is on the right of x-axis, upward on the y-axis, and in front to the z-axis. So, the resultant or the vector S is from the origin position to the point of the box, that is not parallel to any component. State the physical meaning of dot or scalar product and state the physical meaning of cross or vector product. For example, we have two vector A and vector B, and we have an angle theta from that two vector. So for the physical meaning of vector A dot B, okay, when we have two vector A, B, so A dot B is the magnitude of B multiplied by the component of A parallel to B. So for vector A, that is parallel to B, so this is the B. Okay, so when A parallel to B, it is actually A cos theta. That's why for the physical meaning of A dot B, it is AB cos theta. For the physical meaning of A cross B, okay, we have two vector A and B. Okay, so this is the angle theta. So the physical meaning is the magnitude of B multiplied by the component of A perpendicular to B. So this is the vector A. Okay, so vector A, when it is perpendicular to B, okay, so this is the vector B, and when it is perpendicular to B, it is actually A sin theta. That's why the physical meaning of A cross B is actually A cross B equal to AB sin theta. Direction of cross product is determined by corkscrew method or right hand rule. For example, we have two vector A and vector B. So when A cross B, it will product a vector C. So to determine the direction of vector C, okay, first point your four fingers to the direction of the first vector. So this is the vector A. Okay, and this is your direction for the four fingers. And then second, swap the four fingers from the first vector toward the second vector B. So this is the second vector by refer to the direction of your palm. So that the direction of your thumb will refer to the direction of the vector product, which is C. Or based on this example, it is pointed upward.